So once you have the either Docker image installed and up and running, or on your host machine using Python, we're going to want to actually get going and use PyMINEr. So in the example data set that I had for you, we can do it, I'll show you a couple different ways, interactively from the command line, or from within Python. So you just import from PyMINEr.PyMINEr, import PyMINEr analysis, and then you would do something like PyMINEr result equals PyMINEr analysis, infile equals, let's see, what was it called? Airway merged .txt. This can be relative or absolute paths. Species, this is mouse. And we do have a gene of interest file. And for this, we're going to do affinity propagation clustering, in which case we want to say AP clust equals true. There are a couple other options. You could also do AP clust equals true, and then also throw in AP merge equals true. This gives you a slightly fewer number of clusters. This is mostly useful if you have a fairly large data set, but not really large. AP clustering on its own is good for smaller data sets like the example one, but you can also do locally weighted Louvain clustering, in which case you would do Louvain clust equals true and get rid of the AP clust. By default, right now it uses a form of spectral clustering, but I've found that some of these other options can yield better results. So for this one, we're going to do AP clust equals true. And then click enter. And off and away it goes. And it'll take a few minutes to run, but once it's finished, I'll come back and we'll walk through it together. So if you, instead of doing it interactively within Python, you would like to run PyMINEr from the command line, it's actually quite similar. So all you have to do is type out PyMINEr.py. Here we can, just with -h, print out the help section, and there are plenty of options here. Some of the most commonly used ones will be AP clust for doing affinity propagation, AP merge for doing a post analysis on the affinity propagation that merges clusters that are too similar to each other to really be different. And then on larger data sets, you'll almost definitely want to use Louvain clustering. But if you actually have your own groups already identified, if you like to use Seurat for that sort of thing, you can pass in a file to manual sample groups that has two columns, where your first column shows the cell ID, which will, as in a normal format, be the column header in a matrix. And your second column will be the cluster number, starting from 0, going up to however many clusters that you have. All right, so using similar syntax to how you would interactively in Python, we'll do PyMINEr.py-i or infile, and we'll do airway merge.txt, and then genes of interest, and then species, musculus, and in this case, again, we'll be doing affinity propagation, AP clust. And that's it. The same analysis is underway now using the command line syntax. And again, I'll have another video to walk you through the results.